Yeah, thank you very much. I realize should have maybe labeled my talk a bit differently because this is not about sustainability in the sense that you might think about. This is about how we can sustainably scale Ethereum in a way that is sustainable for the long-term future of Ethereum. Um, I'm shortly to me. I work at the Guest team, which is one of the client implementations at Ethereum. I work for the Ethereum Foundation, and recently I kind of switched gears a bit, and I started being a started co-leading the scaling track at the Ethereum Foundation, where we try to improve the L1 mainnet. And yeah, before we can really dive in, I want to. Um, could you guys maybe stop chatting there or close the? Thank you. Um, I want to introduce three things that I want to that I'm going to reference throughout the talks. What is special about Ethereum? Ethereum has smart contracts, what that you all already probably know. Those are small programs that can execute arbitrary functionality. In these programs, you have something called opcodes or operations. For example, one opcode could be adding two numbers together. One opcode could be multiplying two numbers, and so on. The EVM is the environment where these programs are executed, and nodes are the software on the clients, on the machines that are distributed throughout the world that execute and verify these transactions and these operations. Ethereum is a global community. We have over 16,000 nodes that verify every single transaction. So whenever you send a transaction in the Ethereum network, it will get distributed around the world. This is only a very small subset of the nodes, but that are shown here. But the problem is with these 16,000 nodes is a block in Ethereum is produced every 12 seconds. In Bitcoin, it's roughly every 10 minutes. That means we have way shorter time to distribute the block around the network. And so we have a way of limiting the size of the block, which is called the gas limit. For every single operation that you use, you pay a certain amount of gas, and we limit the size of the block by putting in the gas limit. The gas limit for a really long time, as you can see, between 2022 and the beginning of this year, set around 30 million gas. And during this year, we already started increasing it from 30 million up to 36 million at the beginning of the year, and to 45 million very recently. What does this mean? Whenever we increase the gas limit, that kind of has a direct effect on the cost of the transactions, because it means we have bigger throughput through the network, and so the same transaction load will actually decrease in price. And as you can see here, this is not the same timescale as the previous chart, but it's from January 23 to now. And as you can see here, the part that I put red on the previous slide is only this little part here. And you can see, since we've increased the gas limit, the transaction fees have decreased substantially. Increasing the gas limit comes with problems. We might have operations that take too long, that are mispriced, and so what we do when we try to sustainably scale Ethereum is, first of all, we want to identify the operations that are the slowest. So, for example, a multiplication costs 5 gas, an addition costs 3 gas, and now we see that the multiplication is actually, it's the slowest operation in all of the clients. And how we do this is we started creating a new benchmarking framework that Ethereum and all of its forks and all of the L2s can use to benchmark their clients. And then we try to optimize this away. So we have these are all the operations, and we have one operation that is actually kind of bad, and we try to optimize it. And we optimize it by either by improving the client implementations of this specific operation, where we see, okay, it's kind of bad. And once we optimize it, we can scale. We can increase the amount of gas limit in a block again. We can raise the gas limit until the next operation becomes a concern. But with improvements in the clients, we can only scale so far. What we also need to do is we need to try to homogenize the pricing across all of the operations. So if we see that the multiplication is really slow, and we have already improved all of the implementations, and we cannot improve them anymore, then we need to reprice it compared to the addition operation. And so this is something that we already do quite often. And for example, in the next hard fork, we are going to increase the price of the modular exponentiation by roughly 3 times because it is mispriced compared to all of the other operations. And another aspect of this is previously we mostly focused on compute because it's the easiest to test, it's the easiest to change the clients, and it's the easiest to price. But we also want to move to a world where these other resources that we have on our nodes, data, state, and compute, are roughly in the same ballpark. That means that we are maxing out the resources that we have on the nodes. It is very important for us that we don't require users to have big data centers in their home or outsource all of their operations to AWS or these other big providers. And this is how we can use up all of the resources that the people have in their home, that are staking, that are following the chain. And there are some features related to this pricing homogenization across resources. For example, multidimensional metering is something that we are looking into for Glamsterdam. And as I said, we are building a benchmarking suite right now. As you can see, it's not a great picture, but it shows all of the benchmarking runs, and you can see different operations take differently long, and you can see client improvements between runs. This is when people kind of update their software. This comprehensive benchmarking suite is really nice because we can give this internally to projects that we have. For example, block access list is one of the features that we would like to have in the next hard fork. And in order to make sure that block access lists are actually bringing the benefits that we would like it to have, we can use this benchmarking suite. But we can also give it to L2s, we can also give it to other chains, not going to give it to other chains, but other chains can use it because it's open source and you can just run it yourself. And we can clearly see, even in this picture, you can clearly see, okay, there's a huge discrepancy between the different opcodes. You have some operations that are in the 10 million gas range, 15 million gas range, and there are some operations that are in the 60 million gas range. And ideally, this should only be one line, because then all of the operations are roughly priced equally. And this benchmarking suite is also part of EEST, the executable execution spec test. No, executable execution spec tests, which is an effort by the Ethereum Foundation to provide testing for all Ethereum clients and all Ethereum implementations, or all EVM implementations. Other chains can also use this test suite. And another aspect of all of this is state. As I said, there are kind of three key resources that we have on the nodes. It's data, like all of the data that you send to the node, that the node sends to other nodes. The bandwidth of your node is one of the key resources. We can take care of this with benchmarking the network, with creating these test suites where we simulate different nodes and see with a throughput of, I don't know, 30 megabits per second, everything works fine. But if you go to a throughput of like 50 megabits per second, then something breaks. And the third key resource that we have is state. State includes all of the all of the accounts, all of the balances, all of the smart contracts, and everything that is stored within the smart contracts. State takes roughly 100 gigabytes in Ethereum, and the state grows roughly by 5 gigabytes a month. If we 10x the gas limit, it would grow roughly by 50 gigabytes a month. And you can see 5 gigabytes a month, that is kind of sustainable. That is roughly how we see the size of SSDs improve over time. If you go to 50 gigabytes a month, that is not how we see SSDs improving over time. That would mean that within a couple of years we would have terabytes worth of state, and that is not good, because that would mean that no one can store the state anymore, or you would need very special purpose-built hardware to store the state. And BloatNet is one of the initiatives that we also have, that we also started within the Ethereum Foundation in order to benchmark how accessing the state will look if we have bigger network sizes. So if we have 2 times the state size, 4 times, 8 times, 10 times mainnet state size. So if we go to like a terabyte of state, accessing one piece of the state, like reading a value from a smart contract, is going to be much slower than if the state is only 100 gigabytes in size. It's not 10x. The speed decrease is not like 10x, but it's still like, I think, like 2 or 3x, and we would need to take care of this or think about this in the repricing stuff. And BloatNet is a new initiative where we try all of this, and where we specifically think about state. That's it for me. As I said, I should have probably named the talk a bit differently, because I think a few people were kind of expecting something different. But yeah, thank you for listening to me, and I hope you will take something home with you. We would like to increase the scale of Ethereum significantly. Our current plan, as I said, we went from 30 million, 50% up, to 45 million until now, and we would like to be at roughly 100 million at the end of the year or the beginning of next year. So roughly a 3x improvement, or more than a 3x improvement from the beginning of this year. And those are improvements that we think that we can hit only with improvements in the clients and some of the repricings. And then there's a longer term timeline where we're also looking at where we would like to go to 300 million gas, but going to 300 million gas, which is a 10x improvement from where we were at the beginning of the year. This is going to be bigger architectural refactoring that we need to do within Ethereum. And this will take a few years. Thank you very much for listening to me.